Okay, so today we're looking at parallel and perpendicular lines. Okay, so our learning intention is to gain the knowledge and understanding if two or more linear relationships are parallel or perpendicular to each other. Okay, parallel being that they're equidistant from each other. Yeah, and perpendicular meaning they form a right angle when they intersect. Okay, so you'll be successful if students can identify that lines are parallel, and they're parallel if the gradients are equal. So if the gradient of the first line is equal to the gradient of the second line, well then they are parallel. Yeah. Or identify that lines are perpendicular if the product of the gradients is equal to -1. So if I have one line, if that gradient's m1, and then I have another line and that gradient's m2, if I times it together and get -1, then the lines are perpendicular to each other. Let's do some examples. We want to find the gradient of a straight line that is parallel to y equals 3x minus 4. Well, this is in the form of y equals mx plus c, where my m is my gradient, and in this situation, my gradient is 3. I want it to be parallel. All right, so I want to find the gradient of a straight line. Yep, that's parallel to this. So any line that the gradient, any line that has the gradient of 3 will be parallel to this line, right? So I could get y equals 3x plus 7, y equals 3x minus 2, y equals 3x plus 999. It doesn't matter. They will all be parallel because the gradient of this, the two lines will be equal. If they're perpendicular, well then the products will have to be equal to -1. All right. So I know what my first gradient is. That's 3. So my second gradient has to be -1/3. So a line that has a gradient of -1/3 will be perpendicular to y equals 3x minus 4. And that's the symbol for perpendicular, right? That little upside down T. Okay, now we want to find, here's another example, find the equation of a straight line that passes through a point, 7, 4, and is parallel to this equation. Okay, once again, it's in the y equals mx plus c, so my gradient that I want is 3. Okay, and it has to pass through this point. So I'm going to use this formula, y minus y1 equals mx minus x1, which we saw in the last lesson. The gradient that I want or require is 3, because I want it to be parallel. And my point that I have is 7, 4. Cleaning this up, I get 3x minus 21. Y equals 3x. I'm going to add to 4, so it becomes 17. Okay, so that line is parallel to this line, and we can tell that it is. Yeah, and it's still but this line passes through the point 7, 4. Okay. Next example, I want to find the equation of a straight line that passes through this point, but is perpendicular to this. So here, there's my angle, so there's my gradient. I want something perpendicular to that. I don't want it parallel. So the products must be equal to -1, right? So if my first gradient's -4, divide both sides by -4, I want a gradient of 1/4. Okay, or the negative reciprocal of this. Yeah. So I've got this point. Using my point gradient formula, my y is -4. My gradient that I really want, because I want it to be perpendicular, is 1/4. And my x value is -5. Cleaning this up, I get y plus 4 equals 1/4 x plus 5 over 4. I leave it as a fraction. Sorry. 5 over 4 minus 4. We could get this, which would be in the gradient intercept form. Yeah. Or we could get times both sides by 4. We can get 4y equals x minus 11. So x minus 4y minus 11 equals 0. And that can be my general form. Yeah, it depends on which way the question wants you to answer it. Okay, so that is how to calculate. So if the gradients are the same, the lines are parallel. If the gradients multiplied together give you -1, then they are perpendicular. Yeah, you might see this. You might see m1 is equal to -1 over m2, and that's fine. Yeah, that'd be the same. Okay, so good luck. Sorry, I forgot to do this example. So just before you go, let's do this one. This question says to show that the line joining 3, -1 and 2, -5 is parallel to the line of this. This is important. In an exam, we have a show that. So we've got to make sure that through our working out, we are clear and explicit on showing that these lines, all right? So something such as we can do let line 1 be x squared minus 2y minus 3 equals 0, right? And line 2 be the line joining 3, -1 and 2, -5. Okay. So in line 1, right, we get ax minus 2y minus 3. We can rearrange that into ax minus 3 equals 2y, and we get 8, that gives 4x minus 3 over 2, and this is the point gradient form. All right, then m1 is 4. All right, so line 2, we're going to go, we want to find the gradient. M2 is going to be equal to y2 minus y1, x2 minus x1. We get -5 minus -1 and 2 minus 3. That I'm using that as my first point, and that's my second point. Cleaning this up, I get plus minus -4 over -1, which I get a positive 4. Okay, so m1 equals 4 and m2 equals 4. All right, so finishing up as m1 equals m2, which equals 4, both linear relationships or equations are parallel to each other. Okay, and that's how we show that the line joining 3, -1 and 2, 5 is parallel to ax minus 2y minus 3. Okay, you need to be quite clear of what you're defining and be very explicit of how you get there. Okay, thank you.